Let's talk about Simon. And Simon wants to spend the day at the arcade. His mom drops him off at 1 p.m. and will pick him up at 7 p.m. Simon wants to spend his time bowling and playing laser tag. Simon has $28 saved up and bowling costs $5 an hour. And laser tag costs $4 an hour. If Simon wants to spend all of his money, how many hours should he bowl? And how many hours should he play laser tag? All right, that is our word problem. We have a big paragraph of information, and we need to figure something out. So how do we tackle word problems? We use our 4-step method, as we've learned, and the first step is to understand the problem. And to understand the problem, we need to ask these 4 questions. The first question is, do you know all the words? Looking back at our problem, we're talking about an arcade. That's a place you can go to play games. And Simon wants to bowl and play laser tag. Let's say that you've never heard of bowling or laser tag, but you've probably heard the word play. So you know that Simon is playing some game. And he's playing 2 games, one game called bowling and the other called laser tag. Other than that, we're looking at costs, so the price of playing bowling and the price of laser tag. So it seems like we have a good understanding of the words here. Let's go ahead and check that off. Going to the next question, what are you looking for? Usually, you can find that in the last sentence. We see if Simon wants to spend all of his money, how many hours should he bowl? And how many hours should he play laser tag? So let's make a note of that. We're looking for the number of hours that Simon is bowling and the number of hours Simon is playing laser tag. So right now, we don't know how many hours he should bowl and how many hours he should play laser tag. Those are unknown numbers. So let's make a variable to represent those. Let's say that the number of hours Simon is bowling is B, and the number of hours playing laser tag is L. So this question is, what are you looking for? And in Algebra 1, you can usually represent what you're looking for with a variable. So we have B for bowling and L for laser tag. So we're going to work with B and L in this problem and try to figure out what they are. What is the number behind the mask? Okay, moving on to the next question. What info are you given? So for this question, we want to find the important details. If you look at our first sentence, it says Simon wants to spend the day at the arcade. That is information, but it's more like background information. It's just setting up the scene. Remember, we're looking at a real world situation, so that first sentence just tells us we're at the arcade. We don't really need to make a note of that. But what are some specifics we're given about the situation? Well, in the second sentence, we see that Simon's mom drops him off at 1 p.m. and then we'll pick him up at 7 p.m. Why is that important? Well, it tells us how long Simon is at the arcade. We're trying to figure out how many hours he's bowling and how many hours he's playing laser tag. It can be helpful to know how long is he going to be there overall. And if his mom drops him off at 1 and picks him up at 7, there's 6 hours in between there. So let's make a note of that. Simon will spend 6 hours at the arcade. Okay, so far we know that Simon is going to spend 6 hours at the arcade, bowling, and playing laser tag. Moving on to our last question. What requirements or conditions are given? We're told that Simon has $28 saved up, and he wants to spend all of his money. So that's a requirement that this problem gives us. Simon wants to spend exactly $28. Okay, now we've answered our 4 questions and made some notes along the way. We should have a good understanding of the problem. That means we can move on to step 2. Step 2 is to make a plan, and we have a number of tools to help us with that. And the first question there is, have you seen this type of problem before? This problem is dealing with money, and Simon is using his $28 to purchase bowling hours and laser tag hours. If you work through the video on word problems for linear inequalities, we saw a similar problem there. In that case, we had Aditi spending money to buy some donuts. In a similar way, we have Simon spending some money to buy some hours at the arcade. So we have seen this type of problem. And if you did that problem on linear inequalities, it's a good idea to find that and see if it can help you here. Okay, let's look at the second question. Is all the info in the problem useful, or is some of it unnecessary? Let's take a look at the problem. It seems like we've marked a lot of it, and I don't think that anything stood out as random or unnecessary. So I think that we're good on that question. Seems like everything's useful. Moving on to the next question. Do you know any useful equations or formulas? If you notice, when we did step 1, we actually discovered an equation. Right here. The number of hours Simon bowls is B, and the number of hours he plays laser tag is L. And those hours that he bowls and plays laser tag, those hours have to add up to 6, because he's only there for 6 hours. So we can say that the number of hours B plus the number of hours L is equal to 6. We don't know how long he's going to bowl and how long he's going to play laser tag, but those two numbers have to add up to 6. And if you saw the video with Aditi at the donut shop, you know that there's a second equation that we can write, dealing with the cost. We know that Simon wants to spend exactly $28, so the cost of bowling plus the cost of laser tag has to equal $28. So we figured out our first equation from step 1 in this method, and our second equation we knew from a previous problem. Previous problems, things that you've learned in the past, those are part of your toolbox. You can use them to help you with new problems. And our next question actually asks us that. Do you know a related problem that can help you here? Yes. The related problem is Aditi's problem. Again, you can find that problem in the Word Problems playlist. That was the problem on linear inequalities. Okay, the last question. Can you draw a table, graph, or picture? I guess we could. Looking at our first equation, we have b plus l equals 6. And imagine if we had, instead of b plus l, we had x plus y equals 6. If you subtract x from both sides, that would lead to y equals negative x plus 6. That is a linear equation. And if you wanted to, you could plot that on an xy chart. It can help visualize this problem. But again, instead of x and y, we're talking about b and l. So our equation would be L equals negative b plus 6. So instead of x and y, we have b and L. And we could plot a line. However, we wouldn't look at the entire line. Let's zoom in on that. We're talking about a real-world situation with the number of hours bold and the number of hours playing laser tag. Those number of hours have to be greater than 0. So we can't use any part of the line that has negative b or l values because that doesn't make sense. Simon can't play for a negative number of hours. He can play for 0, 1, 2, 3, 4, but he can't play for negative 3 hours. So we'd only focus on values in this top right area. And drawing this chart might help you understand the problem a little bit better. However, as we'll see, we can solve this problem without a graph. Okay, let's zoom out. So on the last question, technically yes, we can, but we don't need to, because if we look back at our second equation, the cost of bowling at the arcade is going to depend on how many hours Simon wants to bowl. So it's going to depend on B. And similarly, the cost of laser tag is going to depend on how many hours Simon wants to play laser tag. So it depends on L. So our first equation has B and L, and our second equation, when we simplify it, will also have B and L. So what we're going to have is a system of equations. So we can add an extra note. A related problem that we know is system of equations. So now that we've made all these notes using our tools, our plan will be to focus on our two equations, and we're going to simplify the second one in terms of B and L, and then solve it as a system of equations. Okay, now we can move on to step 3. Step 3 is to carry out the plan. So let's bring down our two equations. Looking at our second equation, let's think about the cost of bowling. The cost of bowling is going to depend on how many hours Simon wants to bowl. If he bowls 1 hour, it's going to cost $5. If Simon bowls for 2 hours, it's going to be $10. In other words, it'll be 2 times $5. $5 is the cost of 1 hour of bowling. You just multiply that by 2. In a similar way, if Simon bowls for 3 hours, it'll be 3 times $5. Now we don't know how many hours Simon's going to bowl. That's what we're trying to figure out, but we called it B. So if we follow our pattern, if Simon bowls for B hours, the cost is going to be B times $5. B is a number in disguise. It'll be how many hours he plays, and we just multiply that by $5 an hour. So we can represent our cost of bowling as B times 5. In a similar way, laser tag costs $4 per hour, and Simon's going to play laser tag for L hours. So it's going to cost him L number of hours times $4. So let's rewrite these two equations. We have B plus L equals 6, and B times 5, which we can write as 5 times B, plus L times 4, or 4L, equals 28. So now it's easy to see we have a system of equations. And we've learned two ways to solve a system of equations. We can use substitution, or we could combine these equations. If we wanted to use substitution, we could take our first equation and subtract L from both sides. That would give us B equals negative L plus 6. And now we know that B equals this piece over here. So we could substitute that into our second equation, and we could solve for L. However, the way that our equations are set up, it feels natural to combine them. We have our B's lined up and our L's lined up. So when we combine, we need to make sure that one of the variables disappears. It doesn't matter which variable disappears, as long as one of them does. So let's make the L disappear. How would we do that? When we combine these equations, we're going to have a plus 4L on the left side. So we're going to need a minus 4L up here so that it disappears. In order to get that, we need to multiply our top equation by negative 4 on both sides, because when we distribute that negative 4, we're going to get our negative 4L. So let's clean that up. On the left side, distributing that negative 4, we'll have negative 4B plus negative 4L, or just minus 4L, equals 6 times negative 4, which is negative 24. And we can keep our second equation the same. Now we're ready to combine. We'll combine the pieces on the left side and the pieces on the right side. Negative 4B plus 5B gives us just 1B. And then negative 4L plus 4L makes the L's disappear. So we just have our 1B on the left side. Going to our right side, we have negative 24 plus 28. That would give us 4. So B is equal to 4. So if Simon wants to spend all of his $28 at the arcade, he's going to have to bowl for 4 hours. And we know that the number of hours that he bowls plus the number of hours he plays laser tag is equal to 6. So if B is equal to 4, that means that L has to be 2, because 4 plus 2 equals 6. So we can conclude that to spend all $28, Simon needs to bowl for 4 hours and play laser tag for 2 hours. So we've carried out our plan and found our answer, but we need to look at our final step in the method. We need to check the solution. We need to ask, is our answer reasonable? Well, Simon's going to be at the arcade for 6 hours, so it makes sense to have numbers like 4 and 2, because 4 plus 2 gets us to our 6 hours. If we had an answer of 10 hours or -3 hours, those would be unreasonable. Simon can't play for more than 6 hours, and he definitely can't play for a negative number of hours. If we got an answer like 10 hours or -3 hours, that means we need to look back at our work and find the error. Most likely, we've made a little mistake when we're carrying out the plan. If we can't find anything there, maybe we made an error with our actual plan. Maybe our plan could use some improvement. If we can't find anything to fix here, maybe we didn't understand the problem. So, breaking down our problem into these 4 steps in our method, it helps to stay organized and figure out where you went wrong. However, in this case, it looks like our answers are reasonable, so we can check that off and we can be confident in our answer.